Hello, everybody. We're going to do a little nuclear chemistry and why is it so important? Why should I care about nuclear chemistry? This is why. So, first, nuclear chemistry is the study of atomic nucleus and any changes that they occur, like fission, which is splitting of the atom, which happens in nuclear power plants and bombs, or fusion, which happens in the sun. Okay. Now, radiation is everywhere. What kind of radiation? It's a process that travels energetic particles and waves through space, alpha, beta, gamma, and it's everywhere in the universe. There's natural, there's cosmic from outer space, there's terrestrial from the earth, there's internal inside of us because we ate the radioactive bananas. And of course, there's man made ones like TV, X rays, smoke detectors, and nuclear medicine, which we'll get to shortly. Now, talking about alpha, beta, gammas, here's the penetrating ability. Alpha particles, which are helium nuclei, can be stopped by paper. Beta particles, electrons, can go a little further and are stopped with plastic. And it's those gamma rays that go really, really far. How can you tell there's radiation? Well, the way you can tell is by using a Geiger counter, which there's a picture of one that looks just like this one there, and there. And we also have another one over here that also works as well. And you can't feel radiation, but you use a Geiger counter to detect it. And over here, one of those strange things to detect radiation is over here, uranium glass, which I can show you how the Geiger counter works, and we'll do some radioactivity tests just for fun because I like to use it. So here's a little Geiger counter. It has a little meter on it. There you go. And when I hold the button down, it lights up and it detects radiation. Let's listen. That's background radiation. But let's try something that we might have at home. Ooh, a smoke detector. Don't open up your smoke detector because inside there's that little black box there. And what's inside there? Let's see. Oh, there it goes. Ooh, something radioactive in there. What could it be? It's americium, which is a man-made element, which we'll learn about later, and it's in our smoke detector. So you should have one of these at home. Let's see what else you might have at home. I don't know. Something that looks just like in the picture down there is uranium glass, and it glows really cool under fluorescent light, which is in the picture. But let's listen to the radiation coming off of this. Ooh, look at that radioactive uranium in there. And it makes it this really pretty green color. That's why they put it in there, but they don't make it anymore. Jeepers, I have no idea why. And then, of course, another way to tell is that, ooh, there's bananas. Well, in bananas are potassium. This is a product that has potassium chloride. You can buy it in the store. Let's listen. Ooh, sounds radioactive to me. Oh no, is that dangerous? Well, not really. Let's talk about these. They have a cute little tester on it. That's what that little button is. Let's listen to what that sounds like. Uh-oh, that's dangerous. Mr. G, I shouldn't have that in my house. Well, watch this. The further away you are, the less radiation you're exposed to. Interesting. Now, I wouldn't eat it, I wouldn't touch it, but keeping it far away is a good thing. So, Geiger counters are really cool and fun to play with. Okay, let's see what else we got. Oh, bananas are also fun, but I don't have any bananas. Sorry. Now, talking about radiation, what radiation is really bad? Well, let's see. Radiation that's bad is something called ionization radiation, ionizing radiation. And what that does is that we'll learn later, it knocks the electrons out of the atom. And that's called ionizing. And we don't want that to happen because ionizing radiation is the kind of radiation that causes cancer. And we don't want that. So let's take a look at what the sources are that could cause cancer. It's very interesting to find out that 55% is from radon. And look at that. Natural sources, radon, which comes from the ground. We'll learn about that in a minute. The internal, that's inside of us, we have natural radiation inside of us from all those radioactive bananas we ate. Terrestrial, from the earth, can't escape from the earth, and cosmic, it's coming down from outer space. So if we dig a hole in the ground and hide from outer space, we're going to get the terrestrial radiation. And if we go in outer space, we're going to get the cosmic radiation. So radiation is everywhere. You just need to minimize your amount. How do you minimize? Well, X-rays, they put the lead vest on you to protect you from those X-rays, which we saw on the penetrating ability. Internal, you can't do anything about that. Terrestrial, you can't do anything about that. Cosmic, you can't do anything about it. Consumer products, like these, or maybe other radioactive things, and maybe nuclear medicine. And we'll learn more about that in a minute. So where does this radon come from? Well, here in beautiful New Jersey, radon, and here's a cute little map of New Jersey. Radon is a big issue here in New Jersey, as it is among many states across the United States. And what happens is that in the ground, there are minerals that contain radioactive elements. And those radioactive elements, here's one of them, is radium. And this radium in the ground radioactively decomposes, gives off an alpha particle, which is also a helium nucleus, which we're going to learn about in a minute, and radon gas. So this is an element that breaks up into, it's in a mineral, and it breaks up into two different gases. And one of those gases is helium, and one of those gases is radon. Helium, if it can escape out of the ground, escapes out of the ground, just like a balloon, goes whoop out into outer space. The radon, on the other hand, is low on the periodic table, heavy, dense gas. And what it does is it stays in your basement. So unlike helium, which would escape out of the roof, here it gets stuck in your basement. So if you are in one of these areas, you have to get radon tested in your house to make sure that radon is not in your house. And if you do have radon, what they do is they do remediation and they get fresh air and circulate the air in, just like you want to get fresh air, get the radon out, fresh air in. So radon, cause of cancer. So, Mrs. G, but I don't smoke. I know you don't smoke, but you're breathing in radon. Sorry. And what about that helium? Let's talk about that one for a second. So radon, big issue that you might have in your house. Where does helium come from? Balloon store? Party City? No. That's where you buy it, but guess what? It comes from the radioactive decay of those heavy elements. It's beta particles. So in the ground, the beta particles go boop, and then they turns into helium. And if they can escape, they go whoop out into space. If they're stuck, just like natural gas and oil get stuck in the ground in these little pockets under salt reservoirs, and that pocket builds up over millions of years of helium, and oil and gas builds up millions of years, and then we drill a hole and boop, out comes the gas. And that is where we get our helium from. So who gets all this helium? I wonder what countries. Well, obviously a country that has gas and oil. Let's see. Oh my goodness, it's the United States. We are the big producer of helium. Now, Qatar is also a big producer of helium because they have obviously natural gas. But look at all these other countries. Small percentage, very small percentage. So we're very lucky here in America that we have lots of helium. Other countries don't have the helium. So when the helium runs out, it's not going to be a good thing. So we got MRI scanners. We use helium for welding, laboratories, and only 8% balloons. Silly Americans, we use balloons. Okay, so talking about radioactive materials, let's talk about the stable elements. These little black guys in the middle are stable elements, and then the guys on the outside are radioactive. And the last stable element way up there is number 82. That is the last stable element. Now, of course, who's 82? Ooh, well, 82 is lead. Lead, the last stable element. But of course, there are other ones. Uranium is the highest that we have naturally abundant. Okay. And you can find uranium in the ground. That's where we get the stuff for the bombs. And there's also these other ones. Now, this is a little out of date because this one is a little bit better. It's got more spots in there. The new elements, we keep on getting new elements, and we'll learn about that also at the end. But all those new elements are predicted to have this little section up here that's going to be another island of stability. So here it's very stable, then it's unstable, and then there's some more stable elements here, like americium, which is in our man-made element in our smoke detector. And then at some point in time in the future, they're going to have new elements that might be stable. And we're going to learn all about them when they find them, but they haven't found them yet. Okay, so let's talk about the radioactive decay. Now, all those radioactive elements have a decay cycle, and it's really interesting because it's like each of them has their own. So let's just take a quick peek at this one because it has radon hiding in there. You'll see in a second. So in the ground is uranium-238, which has a half-life of 4.4 billion years. So it lasts a long time in the ground. Then it gives an alpha decay to thorium, then a beta decay to proactinium, and then a beta decay down to uranium-234. And that's good for half-life of 245,000 years. Nice long time. Then another alpha decay goes down to thorium, and then another alpha decay goes to radium, which is one of the elements that we just saw a minute ago. And this radium-226 has a half-life of 1,600 years. Well, so it's in the ground. All of a sudden, boop, it gives off an alpha particle. Another one. Look at all these little alpha particles. That's helium coming out. Out comes the radon. The radon comes up. It's near the surface. It's able to escape. Has a half-life of 3.8 days. Means it's pretty reactive, pretty radioactive. So it's going to sneak up, go into your basement, and then all of a sudden, boop, it's going to give off an alpha particle, turn into polonium. And then in 3 minutes, boop, it's going to give off another alpha particle and turn into lead. And then another half-life of 26 minutes, boop, it's going to give a beta particle and go to bismuth. And another 19 minutes, boop, give another beta particle to polonium, boop. And then in 0.0064 seconds, it doesn't stay around very long, another alpha particle, boop, into lead-210, which of course will hang around for a little while. So if you breathe the radon gas in and you happen to be unlucky and it pops, boom, radioactive decay, alpha particle in lungs. Not good because you don't have anything to protect you. Your clothes and plastic can protect you from those alpha particles, but guess what? In your lungs, you don't have plastic to protect you. So boom, alpha particle, boom, another alpha particle, boom, another alpha particle, boom, a beta, boom, a beta, another, boom, alpha. Not good. Okay, so that's why radon is such an important radioactive element that we need to know about so we don't have it in our house. And it comes from the ground. And we're talking about half-lives. So based on half-lives, we could use something called carbon dating. And we're talking about the half-lives before. So what I'm going to do is I'm going to pause here, and then we'll talk about half-lives and carbon dating in a minute.